Good morning, everyone. Am I audible to both the section A and section B?
Yes, sir.
Yes. And my slides are visible.
Yes, sir.
Okay, thank you. Uh, so, welcome all to the first class, an introductory class of Geotechnical Engineering on. Uh, this is also known as your soil mechanics. Earlier, the name of this course was Soil Mechanics 1. Now the syllabus has changed and it has now given it the new name is Geotechnical Engineering 1. So in your uh, four, 4 year courses, you will have Geotechnical Engineering 1, then 2, I think 2 is honor subject, and then Geotechnical Engineering 3. Uh, so when I say geotechnical engineering, that means which is soil mechanics, the most relevant word is soil. So tell me, if I say soil, what what picture comes to your mind? Anyone? If I say soil, what do you think? If I say soil, the word soil, what are the pictures that come to your mind? Or what are the things you are thinking when I say soil? Response, please. Anyone?
Sir, as the aspect of civil engineering, soil is the holds the foundation that
Okay.
holds the
Thank you.
foundation and the settlement and that types
Yes.
of things.
Right. Thank you, Prabal.
And it is
So,
also considered as building material
yes,
like
yes,
concrete,
yes,
steel, and something.
yes, true. So, as Prabal said that in perspective of civil engineering, when you say soil, he thinks of a foundation or building material also. So anything else apart from foundation, building materials, from section A, anyone? Okay, so when I say soil, you may think of foundation, right? You may think of agriculture because in India, this is the most of the land is occupied with different types of crops, and it is related to agriculture also. So soil is related to agriculture. Soil is you can think of a geologist. If you think of a geologist, he also deals with soil and different rock. You have also already covered, I think, the geology course in your first semester. So in a geology subject, you have also read about rocks and soil also. So the term soil can be think in different ways. So in geotechnical engineering on a soil mechanics one, mm, we first will learn or we just have some basic idea about the three basic things, that is the why and how. What is soil mechanics? Why we should read soil mechanics and how we will read this. So first the what. The question is the what. What is geotechnical engineering? So in civil engineering, there are different subjects. You have already started learning your different departmental subjects. So one of the subject is your soil mechanics or geotechnical engineering. So if I try to define the geotechnical engineering, uh, you can say this is the branch of civil engineering that deals with the properties of soils and rocks and their engineering behavior. It explains the mechanics of soils and rocks, and it is focused on the analysis, design, and construction of various supporting structures such as foundations, slopes, retaining structure, embankments, and different roadways, tunnels, landfills. There are many things. So among this structure, some of them may be placed on the soil or on the rock, or some of them may be within the soil and rock mass. So basically, if we try to observe the geotechnical engineering, it can be classified into two major groups. One is soil or rock mechanics, and another one is foundation engineering. Okay. So in the soil and rock mechanics, we'll in your geotechnical engineering on, we will not read too much about rock mechanics. We will focus on the soil mechanics only and some portion of the foundation engineering. We'll discuss later what are the syllabus in the last of our discussion. So there are different ways to define the soil mechanics, okay, such as the soil mechanics may be defined as the branch of engineering which enables an engineer to know theoretically or experimentally the behavior of soil under the action of load. It may be static or dynamic load under gravitational forces, when the water is present in the soil, and when there is difference of temperature. So these things we will learn in the soil mechanics. Uh, Terzaghi, I think you have heard this name. Terzaghi is called the father of soil mechanics. According to him, soil mechanics is the application of laws of hydraulics and mechanics to different engineering problems, which deals with sediments and other unconsolidated accumulation of solid particles produced by mechanical and chemical disintegration of rocks. Here in the last portion, that is sediments and that unconsolidated accumulation of solid particles, which is produced by any mechanical or chemical disintegration of rock, it is a definition of soil. If you try to see this last part, this is the definition of soil. So we'll learn in the soil mechanics the application of laws of hydraulics as well as mechanics in different engineering problems. So simply, we can just say that it is the knowledge of engineering which deals with properties, behavior, and performance of soil as a construction material or foundation support. Okay. This is the different ways of defining your soil mechanics. And what is foundation engineering? Foundation engineering is the aspect of engineering concerned with the evaluation of the ability of the earth to support load and the design of a substructure to transmit the load uh, from the superstructure to the earth. So foundation, we know the foundation, the main principle or main aspects of foundation is to transmit the load from the superstructure to the earth. So in this foundation engineering, we will learn the aspect of engineering which is mainly concerned with the evaluation of the ability of earth to support the load and the design. Okay, so these are the basic difference in soil mechanics and foundation engineering, and in this way we can define this is just preliminary idea of what is soil mechanics and what is foundation engineering. So now we have learned what is soil mechanics or geotechnical engineering. So the main focus of this course is soil. So we should know what is soil. So as we have started that soil can be viewed in different perspectives. It depends on the field of study, who is studying this soil. So uh, for a geologist, the soil is decomposed and disintegrated rocks, which is generally found on the upper portion of the of our earth. That is called crust. So for a geologist, he mainly deals with the upper portion of the Earth's crust. So according to him, it is the decomposed and disintegrated rocks on the upper portion of the Earth. To an agriculturist, it is the substance existing on the surface which supports plant life. So, a agriculturist, he mainly deals with the agriculture and the forestry. That's why, according to him, it is the substance which exists on the surface of the earth and which supports the plant life. He defines the soil in this way. But to an engineer, the soil can be viewed as a material on which we can build foundation of building, on bridges. In the material, we can construct basements, culverts, tunnels, and with the material, we can construct embankments, roads, dam, etc. And also, it the material can be supported with different retaining walls. So this retaining walls is also an important structure which is in your geotechnical engineering one course. So if you try to, in generally, if you try to define the soil, we can say that soil is defined as the naturally occurring uncemented or weakly cemented, aggregate of mineral grains and decayed organic material, that is solid particles, with liquid and gas in the empty spaces between the solid particles. So the soil is mainly consists of your uncemented or weakly cemented aggregate of mineral and decayed organic material, and there will be voids in the solid particles, and in these voids there will be either there may be liquid and gas uh, in between the solid particles. So in this way, generally we can define the soil. So soil is mainly consists of your solid particle, liquid particle, and gas particle. So what is the solid particle? The solid particles is your mineral grains and organic matter, and the liquid may be water, and the gas mostly it is your air, and there may be different gas also that you will learn slowly. So in this way, we can define the soil. Okay. If there is any interruption, please try to inform me, because the network is not that much strong here in my home. So if you cannot hear me, please try to give me a call or try to inform me. The CR of the both the sections are requested to uh, look into this matter. If there is an interruption in the network, or I may get disconnected, so please inform me. So, is it clear, everyone, what is soil and what is soil mechanics? What is the difference between soil mechanics and foundation engineering? We have until now we have covered what is soil mechanics, what is foundation engineering. Okay? So, if you have any question till now, you can ask me.
Yes, sir. How it differs from geology? Actually, it is a
Yes.
smaller part of geology, geotechnical engineering.
Yes, so geologists, they are not they are not concerned with the with your let's say with the bearing capacity of the soil. Suppose we are trying to build a structure, and what type of foundation should I place, and what will be the your dimension of the foundation, how we will design the foundation. The geologist will not deal with these aspects. They mainly deal with the mineralogy of the rocks, what are the composition, and how to identify your rocks. You have already I think gone through the geology course, right? So you know better than me what you have learned in the geology course. So they are not dealing with the construction designing parts. Okay? They are mainly they mainly deals with the material only. Okay? Not on, they don't deal with the structure, the foundations, and all these things I have discussed here. They do not deal with these things like your uh, slopes, retaining wall, roadways, embankment, tunnels, landfills. They are not concerned with these things. They are mainly focused on the material. Anything else? Okay, so if you don't have any more question, I will proceed. Now we'll come to the why. So I think in this portion, Praval, you may get your answer more clearly, that why we should read geotechnical engineering. So suppose we want to build a structure, okay? So what will be the foundation? So if you want to build the foundation, how will we build the foundation? This is mainly we design this foundation or build this foundation based on two criteria. Uh, One is from the strength point of view, that there should not be any failure or any shear failure, because the material soil mainly fails in shear. That's why it is written shear failure. So there should not be any shear failure of the foundation soil. And the second aspect is the settlement. the settlement should remain within the permissible limits. If there is a settlement uh, which is greater than the permissible limit, then the structure, that is superstructure, may collapse. That's why we need to be sure about these two different criteria. One criteria is from strength point of view, and another criteria is from settlement point of view. So suppose we now want to build a foundation. So what type of foundation you will provide? You will learn these things slowly. I am just giving you an overview of this. For farm soil, that means the soil which can bear more load. Uh, this the foundation on that soil is mainly shallow found. We call it shallow foundation. Mainly we provide shallow foundation on that soil, which is farm. The shear strength is more there. So this shallow foundation has different types, such as isolated, combined, and mat foundation. This term is new for you, I think. So these things you will learn later. Just you just think of shallow foundation means the depth of the foundation is less, and deep foundation is depth of the foundation is
Sir,
more.
mat is also called raft foundation. That,
Uh, yes, yes, you may call it that foundation. Yes, right. So what type of foundation you will provide for farm soil? This is a basic overall view, that is for farm soil we provide shallow foundation, but in that farm soil what type of shallow foundation you will provide? So either will be isolated or combined or mat or wrapped, and if the soil strata is soft and there is a hard strata, uh, uh, suppose after 15 meter or 20 meter, then we can provide deep foundation which will provide the which will transfer the load from the superstructure to the foundation through this deep foundation. That means the deep foundation means the depth of the foundation is more as compared to the shallow foundation. So one of the example of deep foundation is your pile foundation. Okay, so here one of the case study, uh, in the MIT Student Center, they uh, were trying to build a school building, and below the school building the soil layer was, you can see in this picture that the first layer is soft soil, and then there is a layer of sand and gravel. Okay, soft soil means this is the load bearing capacity is very less. Okay, and then sand and gravel, and there is another layer of soft soil. The height of this soft soil is more than your earlier two strata, and then below that soft soil there is a farm soil which may be rocky type. Okay, so when uh, they were designing this building, they were designing the building and they were designing the foundation, what type of foundation they will provide. So they decided to provide a slab kind of thing, which is called mat or wrap. So mat foundation they decided to place. But when they observed, they calculated the settlement, they saw that the settlement is huge settlement, means this is more than the permissible limit. So how they are going to construct it? If they want to place the pile foundation, the pile foundation is deep foundation, obviously they can place pile foundation, but this is not that much economical. In order to make this design economical, when you design something, you need to see the economical aspects also. So that's why they decided to place the shallow foundation only, but the foundation was able to bear the load, but the settlement was crossing the permissible value. Okay, so what they digged up the soil, they excavated the soil. Okay, so the total load which was coming from the building, the dead load was 32,000 tons, and the live load, which is 5,000 tons. That means total load of 37,000 tons. Okay, so they excavated the soil. That means they released the pressure from the soil. So they excavated, the weight of the soil was the weight of the soil excavated soil was 29,000 tons. That means what is the net load now? The net load on the soil is now 8,000 tons only. So from 32,000 tons, from 37,000 tons, it becomes now 8,000 tons. So now when they calculated the settlement was very less and it was within the permissible limit. So in this way, they constructed this student center. So when they were constructing this, so the question which was raised was this: how deep into the soil should the building be placed? Like when the engineer went to design this foundation, these were the question which was the concern about the design, which is related to the design. The number one question is what will be the depth of the foundation, or what will be the depth of the excavation? Okay, then what would be would the excavation have to be enclosed by wall during construction to prevent cave-ins of soil? Like when you try to excavate the soil may fall from the side. So will there be a need of a wall during the excavation process? This was also another question. The third question was, would it be necessary to lower the water table in order to excavate and construct the foundation? That means if if you want to excavate the soil, you may face the water table, right? So if there is water table, it will be difficult now to excavate because there will accumulation of water. So would it be necessary to lower the water table in order to excavate and construct the foundation? And if so, what means should be used to accomplish this lowering of the groundwater? How will you lower your groundwater table? So these were the questions. Another question was there a danger of damage to adjacent buildings? Right? You are excavating the soil, you are digging up the soil. So the there are also different buildings surrounding this site. So is there uh, will there be any damage or any danger, any threat to the buildings which are located around this site? The fifth question was how much would be completed mm, how much would the completed building settle, and would it be settled uniformly, right? So finally, what will be your final settlement, and what will the building settle in a uniform manner, or there will be differential settlement? So these are different questions arise when the engineer went to design this building. So in order to know the answer of these questions, you need to learn your soil mechanics. Similarly, if you want to design a deep foundation, that is pile foundation, see here, these are the foundation, these are called pile foundation. The top layer is soft soil, and there is a firm soil, maybe 20 or 15 meter below this ground. So you want to directly transfer the load from your build the load of the building to the firm soil. Then you need to place this deep foundation or pile foundation. So when you want to place pile foundation, these questions may arise. What type of pile should be used? There are different type of piles. There may be concrete pile, there may be timber pile, there may be your driven pile, there may be board pile. So cast in situ pile and also your uh, precast pile. So there are different types of piles which you will learn in your geotechnical engineering 3, I think. So what type of pile should you use? How will you going to calculate the capacity of each pile? What is the maximum allowable load for a pile? That means if you put a pile, what will be the maximum load for that pile? And what will be the spacing if you need multiple pile? If you need multiple pile, if you place multiple pile, so what will be the spacing between these piles? Okay, how should the piles be driven? How you are going to place the piles into the soil? So these are various questions which will arise when you will go to construct the pile foundation. So in order to know the answer, you need to learn your geotechnical engineering course. Similarly, this is another case study. There is a layer of soft soil. Okay, now you want to place a tank on this soil, but when uh, the settlement was calculated, it was found that settlement was more than the permissible value. So it is not possible to place the tank on the soft soil. So how we are going to play? How we are going to construct this tank? One of the solution is you place an earth embankment over here, an embankment which is filled with the material soil, that is called earth embankment, and you keep it for uh, for a time. Then there will be settlement of the subsoil, and when the soil will settle, then you can again remove this embankment, and then you can place the tank. So this was the uh, idea, because if you're going to place the tank directly, the soft soil will settle, and this settlement is more than the permissible value. So that's why the idea is to settle the soil to its maximum value. So that's why you place an earth embankment over this soil, then it will slowly settle, and when it has settled its up to its maximum value, you remove this earth embankment, and then you can construct your tank. So in order to make this earth embankment,
এগুলো একই থাকে, মানে আর্থ ইম্প্যাক্টমেন্ট কেন হলো এটা একবার একটু বলবে?
earth embankment, okay. So what I am trying to say, that this is your a soil layer which is made of soft soil. Okay. Now you are going to place a tank over here. Uh, this is so when the designer calculated the settlement after placing the tank, the settlement is the settlement will be more than the permissible value. He calculated the settlement that is more than the permissible value. So if you place the tank directly over the soil, it will settle, which is the value of which is larger than the permissible value. That means the tank may damage, right? So that's why in order to first settle the soft soil, you construct an earth embankment on the soil. Okay, and when the soil will settle to its maximum value, you remove this earth. That means earth embankment, and then you can now place the tank. Is it clear?
Yes, sir.
Okay.
Sir,
So while
generally what, sir, what, earth embankment is made up of what?
soil, this is a filling material. We are using the soil as building material. Earlier we also said that building material. So here we are, for building of this earth embankment or construction of this earth embankment, we are placing the soil over this soft soil, right? So while constructing this earth embankment, the questions that may arise are how high a fill could be placed. Okay, that means if I want to place this earth embankment, what will be the height of this earth embankment? How fast could the fill be placed? How fast? What will be the rate of placing this earth? What were the maximum slopes for the fill? Uh, what will be the slopes so that it does not collapse? Okay. Could the fill be placed without employing a special techniques to contain or drain the soft foundation soil? Means um, if we place the earth embankment over the soil, there will be draining. Or if there is water in the soil, there will be drainage of water. So should we consider any special technique for the drainage of water? And how much would the fill settle? What will be the settlement of this fill when we are constructing this earth embankment? So these are the questions that will arise, and you need to answer these questions. So only here the main concern is your that this soft soil should settle. Okay, and while constructing the embankment, you should consider the strength also, the strength of this soft soil. You should not make this embankment too high. If you make this too high, there may be a possibility of failure of this soft soil. That means there may be a possibility of shear failure of this soil layer. If the soil layer fails in shear, then our purpose will not fulfill. So we will not make this embankment too high, uh, for which the soil layer may fail. Okay, so we should also be consider this failure of the soil. That's why we should design this earth embankment in such a way, with the height and the slope, that this layer should not fail in shear. Okay, so these are the concern and question when you will construct an earth embankment over a layer of soft soil. So to answer these questions also, you the same answer what why we are learning now, why we should read our geotechnical engineering course. So these are the problems when we go in a site, or we try to construct a foundation, or we try to use the soil as a in different structure. So these questions we will face, and we need to answer these questions. Uh, uh, we need to make sure about the stability of the structure. So in order to answer your questions, you need to you learn your soil mechanics course or geotechnical engineering course. So here also another example of construction material of soil, where you will use soil as a construction material. This is a example of your dam. See, this dam is mainly consists of two parts, that is clay core and your rock toe. Okay? And in between this clay core and rock toe, there is a gravel filter, and on the upstream side there is a rock facing and there is a gravel bed. So why these material have been given? You can just think that in order there is a core of clay, and this clay is the permeability of this clay is very less. So it is used to your to decrease the permeability. That means that the water should not leak through this dam. There should be very less leakage of this water through this dam. That's why we have used, or this clay has been used in order to construct the core. And here some water will obviously pass through this dam, and in order to uh, provide this drainage facility, the rock toe has been provided here. Okay, and the clay should not like flow through this rock toe. That's why a filter of gravel has been placed in between this clay and the rock. And here on the upstream side, it is obvious that if there is no rock facing, then this water, the clay may get flow with this water. That's why the rock facing has been provided. And below the rock facing, there is gravel bed. Gravel bed has been provided, that rock should not get into the clay. That's why a gravel bed has been provided here. So this is an example of dam, and in this dam we use the soil as a construction material. So if you want to construct your dam, there will be many questions. So what should be the dimension of the dam, which is most economical, and also say what is the minimum set thickness of the gravel layers, how thick a layer of gravel and rock facing is necessary to keep any soiling of the clay coat to the tolerable amount. What will be the moisture content and the compaction technique, what are the strength and permeability characteristics of the constructed dam. So there will be many questions if you want to construct your dam. So similarly, to answer these questions, you need to learn your soil mechanics. So there are many other examples also, like in retaining structures are there. So you need to construct this retaining structure in such a way that it should not get failed. The slope, suppose there is a slope and you want to construct a foundation over the slope, so you need to calculate the stability of this slope. Okay. If I construct this foundation, if I this structure, will this slope be stable? You need to calculate this. If you want to excavate the soil, suppose for excavation for a foundation, excavation in order to place a pipeline, we need to excavate for a canal. So if you want to construct a canal, we need to excavate the soil. So how we should excavate the soil? What will be the slope? Okay. Uh, will there be a need of seat wall or any lateral bracing? In order to answer these questions, you need to learn your soil mechanics. So here are the examples. Some typical photos have been placed here. So these are examples of your retaining walls, and here you can see the failure of the soil. This is a slope failure. It was a parking place, and it has failed, maybe due to the shear, and you may see the hazards that has caused. So in order to answer these questions, you need to learn your soil mechanics. Now the final question, how? So how you need to cover all the topics which has been included in your soil mechanics course or geotechnical engineering 1 course. The first we learn about the soil formation, how the soil, about the origin of your soil, uh, and what are the composition of the soil. We learn about the different minerals which are present in the soil, and then we will learn some properties which are called index properties of soil, and then how we learn how to classify the soil. Then we will learn some of the terms when water is present in the soil. Then we will learn about the capillarity, the shrinkage characteristics and soiling characteristics, the permeability of soil, the seepage through soil, and about the effective stress. Then we will learn about the compressibility characteristics of soil, which is mainly compaction and consolidation. And then we will learn the shear strength characteristics of soil. Okay? So these are the key topics in your soil, basic soil mechanics or soil mechanics course or geotechnical engineering on course. So based on this is your syllabus. Okay, so these are the main topics, and these are some details about these topics. So this has been colored in three different color because this course will be covered by three different professors. One professor Narayan Roy sir, he will be taking the this portion which is in green color, and in the blue color this will be covered by Professor Arghoti Biswas, and this highlighted portion will be covered by me. Okay, so the basic part, that is that is the blue color, and then your some green color. Uh, this will be covered by Professor Arghoti Biswas and Professor Naran Garg, and then these parts will be covered by me. So what I am telling these things to you, that one thing you need to learn who will cover which portions, and then the topics which are given, which are in my syllabus, actually in my portion. So that parts actually needs, if I want to teach this portion, you need to learn these basic things. Okay, so there may be some problems in some technical term. So while that's why first I will go through your the topic of shear strength of soil. Okay, the topic of shear strength, this strength or shear stress, actually you have already covered in your, I think, engineering mechanics or structural mechanics course. So I will start from this stress part, stress or shear stress or shear strength part. uh, then Mohr Coulomb theory, that means we learn to first we learn to determine the stress which are acting on a plane. Suppose you have been given a state of stress in a particular plane, then how you are going to calculate the state of stress in another plane, that will be covered, and then we learn the same things in terms by constructing a Mohr circle. Okay. So these theoretical parts, which you need the background of your structural mechanics or engineering mechanics, that I will cover first, and in between we will cover the basic things. Then we will go to the determination of shear strength, how we are going to determine the shear strength of soil, both in your in the laboratory as well as in the field, and then I will cover the rest part. Okay, so that means that lateral earth pressure and then stability of slopes. So if you want some reference, so you can know the reference. The main book which I will follow, that is Basic and Applied Soil Mechanics by Ranjan and Rao, Gopal Ranjan and Rao, S.R. Rao. And there are many textbooks. You can follow any textbook, which one is you are finding more suitable. Uh, these are some of the reference: Soil Mechanics and Foundation Engineering by Murthy, Principle of Foundation Engineering by B.M. Das, Soil Mechanics by D.C. Punnia, and Soil Mechanics by William Lambda and Whitman. So these are the some reference books that will be followed for my portion. Uh, So this is the end of your of the introduction of geotechnical engineering one. So if you have any queries, any question, you can now ask. Anyone? If anyone
Sir,
have any question, yes,
sir,
continue please.
will you share this PDF?
Sorry, Santanu, can you repeat
Sir, will you share this PDF in WhatsApp group?
this PDF? Okay,
Yes,
I'll
sir.
share. No problem.
Okay, sir.
I think so. In section A, there are 62 students, and in section B, there are 72 students. But I can see here that 37 in section B and 54 in section A are present. Okay, so I am not taking your attendance today because this is introduction class and this is not your scheduled class. So from the next week, what I suggest that for section B, you have class on Monday, right? Section B on Monday, and section A you have class on Wednesday. So what I suggest that while I on Wednesday when I take class of section A, I think section B you don't have any class. So I suggest that to combine this class on Wednesday, both for section A and section B, Wednesday at 10 to 11. Is it fine? So the CR of section B and section A, are you present here?
Yes, sir. Yes, sir.
Person? Yeah. So,
Yes, sir.
so I will take class on every Wednesday from 10 to 11. Okay. And I will share the link. I'll try to reschedule this link to Wednesday actually. If it is not possible, then I will create a new link and I will again share with all of you. And everyone, to all the students, I request that please give your email IDs through which you will join the class. Okay, so that I should not like permit everyone for the class because it is very time taking and in between the class there will be disturbance also. So in that Excel sheet, I request the CR of both the section to update all the email IDs, which is through which the students will attend the class. Okay, so please do this
Okay.
this class. And if anyone does not have any more questions, then I will end this class. Okay then, thank you. Both section A, section B.
Thank you.
I am ending the
Thank you,
class.
sir.
Thank you.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.